Hi everyone, this video is how to set up auxiliary outputs on a modular ECU. First I'll explain about the types of auxiliary outputs available on the ECU hardware, because that might affect which ones you select for which functions. Most auxiliary outputs on ECUs switch to ground, with the other side of the load needing to be connected to a 12 volt supply. This is because of the way transistors are made. Switching to ground is a lot cheaper and easier. Modular ECUs have three types of outputs. The first is a push-pull auxiliary output, which can either switch to power or switch to ground. All four of the auxiliary outputs on the M2000 are of this type. Any load that requires being switched to power will need to use this sort of output, and this includes 4-wire stepper motors. So for example, if you want to run a 4-wire stepper motor on an unexpanded M2000 ECU, then you'll need to use all four auxiliary outputs to drive the stepper motor. This output can source up to 1 amp and sink, or short to ground, up to 4 amps. The actual transistors are rated at higher currents than this, but this is where we set the limits so that they have some margin. And these outputs can be pulse width modulated. The second is an injector output, which can also be used as an auxiliary output. These can only switch to ground. The maximum current that we allow is 4 amps, which is the same as the auxiliary output. And these can also be pulse width modulated. The third type is an ignition output, which can also be used as an auxiliary output. In this case, the outputs can only sink half an amp, so they can be used for switching on relays and that sort of thing. This output can also be pulse width modulated, but normally the sort of things that you want to pulse width modulate need more current to drive them. The only example I can think of is if you wanted to pulse width modulate the input to a solid state relay to control a fuel pump or a water pump or something like that. Now, if you expand a modular ECU with one of the mini aux output modules, then you get 6 push-pull auxiliary outputs, so they can provide power or provide the ground side switch. They can all be pulse width modulated, and you can use them for pretty much whatever you like. Now, an auxiliary output can be pre-programmed to be one of a certain number of pre-configured functions, or you can use it as a switch based on any variable inside the ECU. I should explain the variables within the ECU at first. There are about 1,000 variables, and each one of which can be seen on the live gauges window, and you can add them to the monitor panel or on the gauges window within Eugene. You can also watch them on the built-in scope and in the logs. These are separated into different categories to make individual variables easier to find, and if you can't find the one you want, then you can type it into the search bar. I'll start first with pre-programmed logical outputs. Now, these are outputs whose functions are designed into the ECU, and they're normally things that are either 0 or 100% duty cycle. Examples of this would be, say, thermofan stage 1, fuel pump, check light on off, and that sort of thing. There are some other pre-programmed outputs which have a variable duty cycle, which can vary between 0 to 100%. So this would include the idle effort, variable valve timing, pulse width modulated duty cycle, boost control, and so on. Let's have a look at the output screen in Eugene. In this screen, all the outputs in the ECU are listed in accordance with the modules that have been installed in the ECU. On a base model M2000, for example, there are 20 outputs. The first 8 are injector outputs, the next 8 are ignition outputs, and the last 4 are auxiliary outputs. If you have a configuration that uses 6 injector outputs, for example an inline 6-cylinder or a 3-rotor with 2-stage injection enabled, then you'll see that outputs 1 to 6 cannot be changed. But injector outputs 7 and 8 can be modified in the settings. For argument's sake, let's assume that we want to use injector output 7 to be an idle valve which pulse width modulates at 250 Hz. What you would do is select that output and then select the type. Do this by selecting outputs as the variable category and then idle effort as the output channel. Then enter the frequency of 250 Hz. The procedure is the same for a boost control output, but normally in that case you'd run a lower frequency, for example 30 Hz. Let's do a more complex example now. Let's say that we want to drive a 4-wire idle stepper motor. We said before that we're going to need to use the auxiliary outputs 1 to 4 to drive that motor because they need to be able to drive high as well as low. So I'll go to the first auxiliary output, which is number 17, and select it as idle stepper A. We need to enable the drive high selection so that it will provide current to the stepper motor. Then the next one, output number 18, we select that as idle stepper A as well, but this time we invert the output and we also still need to enable the drive high selection. Output number 19, we select idle stepper B and enable drive high, and output number 20 would select idle stepper B, invert and drive high. That way auxiliary output 17 and 18 go to the first coil of the motor and the other 2 go to the second coil of the motor, and they all get energized in the correct sequence then. A 6-wire stepper motor is exactly the same, except that you don't enable the drive high selection. And because you don't need to drive high, because it's a 6-wire, so it gets power on the middle 2 pins, you can use injector or ignition outputs to drive 6-wire stepper motors. So the wiring is the same then, whether it's an idle stepper motor or a metering oil pump or any other 6-wire stepper motor. Now let's look at a more generic variable-based output. In this case, we're going to look at the variable valve timing as an on-off selection, for example on the RB25 engines or the 4AGE 20-valve engines. If you've played with VVT, then you'll know that it needs to come on at about 2000 RPM and turn off at about 5000 RPM. And at higher RPM, it's back in the home position. So for the sake of an example, let's say that we want to use those 2 RPM points with 100 RPM hysteresis. So this means that as the RPM increases from idle, the valve will turn on at 2000 RPM. The RPM will need to go below 1900 RPM to switch off again. If you keep accelerating, when the RPM gets to 5000, and then it would need to drop to 4900 to turn back on again. So to configure this one, we need the RPM variable, which is in the main variables section. So select the output category as being main variables, and then select RPM. Then select the lower threshold as 2000, and the upper threshold is 5000, and the hysteresis is 100. Disable PWM on the output, and the job is done. Now, if you just want a simple threshold-based switch, like, for example, turning on additional fuel pump when the map gets above 130 kPa, or 5 psi boost, then you do it the same way, except you'd need to set the off above setting to be a very high value so that it never gets triggered. For example, 400 kPa or 45 psi of boost. There's also a shortcut here which shows you the pin number on the actual ECU connector and also the name that's been assigned to that pin on the wiring page. You can double click on that shortcut to take it to the wiring page so that you can update it when you change an output function in the outputs page. To check that an output is working, there are a few ways to do it. The easiest way is to go to that output setting in the outputs page and click the invert on and off, and then that way you can tell if the output's actually functioning. For example, if it's a boost control valve, you should hear it clicking. If it's a fuel pump or a thermo fan, then you'll hear it turn on. A second way you can check if the output's working in the ECU is to have a look at the ECU diagnostic page. For each output, you can see the voltage and the current of that pin. So with an output that's switched off, if there's a load connected and the other side of the load goes to 12 volts, then you should see 12 volts on that pin and the current should be very close to 0. If you turn the output on, for example by inverting it, then the voltage should go down to 0 volts because the ECU is pulling that low, and you should see the current increase as well, depending on how much current is drawn by the load. Now if the voltage is 0 even when the output's off, or the current is 0 when the output's on, then that means that the load isn't actually drawing any current, which probably means that there's no 12 volt supply to the other side, or the load's disconnected, or the load's burnt out or gone open circuit. One final point about the outputs page. Because the modular ECUs use switching mode injector outputs, during the off time while the injector is still being driven, that is when it's being pulse-width modulated, the recirculation current has to go back into the 12 volt supply. To keep that current loop area as short as possible, we recommend, and in fact this is shown in our wiring diagram, that the injectors and the power supply for the ECU get their power from the same source. If they recirculate back to a different 12 volt source, then you have a much larger current loop area and correspondingly more magnetic interference generated. You can see my video on ECU grounding if you want to understand this in more detail. So if you're wiring into a car where the injectors are hot all the time, then we really recommend that those injectors be disconnected and instead wired into the power supply that goes to the ECU. This may require increasing the capacity of the power supply that feeds the ECU though. On plug and play ECUs that we do for vehicles where the injectors are hot all the time, then you'll notice on those cars that there's a separate power feed for the injectors for the ECU to recirculate the current back into, and that's what we use for that situation, so that one's okay. It's just the wire in ECUs where you need to be careful about this. This injector flyback voltage pin is also shown on the outputs page, not because you can change any settings relating to it, but as a reminder of which pin it actually connects to on the ECU. Thanks very much.